You've been fasting for 2 days. No food, no cheating, nothing. By every calculation, autophagy should be running at full speed, clearing damaged cells, recycling broken proteins, and rewiring your body from the inside out. But something is quietly sabotaging the entire process. And most people who fast have absolutely no idea it's happening. The culprit isn't stress. It isn't a hidden calorie, it's something you did the night before you even started your fast, and ironically, it's something your body desperately needs to survive. Sleep deprivation is not just making you tired, it is biologically blocking one of the most powerful healing mechanisms your body possesses. And the science behind how it does this will completely change the way you think about fasting. Let's start with autophagy itself, because most people only understand the surface-level version. Autophagy, from the Greek meaning self-eating, is the process by which your cells hunt down their own damaged components and break them down for recycling. Malfunctioning proteins, worn-out organelles, dangerous cellular debris, all of it gets tagged, wrapped in a membrane, and delivered to the cell's recycling center. It sounds almost violent, but in reality, it is one of the most elegant survival strategies biology ever invented. When it works properly, autophagy is linked to protection against cancer, reduced neurodegeneration, stronger immunity, and a dramatically slower rate of cellular aging. The 2016 Nobel Prize in Medicine was awarded specifically for autophagy research. That's how significant this process is. But autophagy doesn't just switch on because you skipped breakfast, it requires a very specific internal environment. And sleep is one of the most critical architects of that environment. Here's something that shocks most people. Your body actually performs a significant portion of its autophagy activity during deep sleep, not during fasting. During the slow-wave stages of sleep, growth, hormone surges, cortisol drops, insulin falls to its lowest point of the day, and mTOR, the master growth signal that suppresses autophagy, essentially goes quiet. This is the biological window your cells have been waiting for. This is when the cleaning crews get to work. In a well-rested fasting individual, these two forces compound each other. Fasting drops insulin, sleep drops mTOR. Together, they create an environment so low in anabolic signaling that autophagy can finally operate without restraint. It's like opening every door in a building and letting the cleaning crew access every floor simultaneously. But when you're sleep-deprived, the architecture collapses entirely. Researchers at the University of Chicago found that just one night of poor sleep is enough to spike cortisol levels into the next day. And cortisol, your primary stress hormone, is one of the most potent activators of mTOR. When mTOR is active, autophagy slows to a crawl. Your cells shift from recycling mode into growth and defense mode. It doesn't matter how long you've been fasting. mTOR doesn't care about your calorie deficit. It only responds to the signals inside your body. And a sleep-deprived body is sending the wrong signals at full volume. Think of mTOR as a traffic light sitting at the entrance of the autophagy pathway. Fasting turns it red, telling cellular growth to stop and letting the cleanup process move freely. But cortisol from sleep loss is like an override switch that turns that light green again. Traffic floods back in, the cleanup halts. And your fast, however disciplined it may be, loses much of its cellular power. But it gets even more specific than hormones. And this is where the science becomes genuinely fascinating. Your cells run on an internal timing system called the circadian clock. Every single cell in your body, not just in your brain, carries its own molecular clock that orchestrates when certain processes should run. Autophagy is one of those processes. Studies have shown that autophagy in the liver, the brain, and the gut peaks at predictable times dictated not just by fasting state, but by circadian rhythm. When you sleep poorly, those clocks desynchronize. The signal that should say, now is the time to recycle, gets delayed, distorted, or completely missed. Your cells lose track of when their cleanup window opens. This is why researchers studying circadian biology have found that people who work night shifts, even when they fast during the same hours as day workers, show dramatically reduced autophagy markers. The metabolic benefits simply don't transfer cleanly when the body's internal timing is fractured. So, what does sleep deprivation look like inside a fasting body in real, measurable terms? A study published in the journal Cell Reports found that chronic sleep restriction reduced autophagosome formation, the actual structures that form around damaged cellular material during autophagy, by a meaningful degree. Even in calorie-restricted subjects, these people were eating less. Their insulin was lower than normal, but their cells were still not cleaning themselves the way they should have been. The cellular machinery was present, the hunger signal was there, but the biological permission wasn't granted because the circadian and hormonal environment was too disrupted to allow it. There's also the issue of what sleep deprivation does to your mitochondria specifically. These are the energy-producing structures inside your cells, and they are among the primary targets that autophagy is designed to clean and remove when damaged. The selective removal of damaged mitochondria has its own name, mitophagy, and it is incredibly dependent on proper sleep. Mitochondria that accumulate without being cleared begin to leak reactive oxygen species, a form of cellular rust that accelerates aging, drives inflammation, and degrades brain function. The cruel irony is that fasting without sleep is meant to clear these damaged mitochondria, but the disrupted hormonal state from poor sleep is exactly what keeps them in place, accumulating damage while the recycling system sits idle. By the way, I'm curious. Have you ever tracked your sleep during a fast? Drop a comment below and let me know whether you prioritize it or whether this is something you hadn't considered before. I personally read through comments and reply. Now let's talk about what happens at the neurological level, because this is where the consequences become very difficult to ignore. The brain is exceptionally vulnerable to disrupted autophagy. Neurons are among the longest-lived cells in the human body. They can survive for decades, but only if their internal maintenance systems are functioning. When autophagy fails in neurons, misfolded proteins begin to accumulate. Clumps of tau protein and beta amyloid, the very substances found in elevated quantities in Alzheimer's patients, are normally cleared partly through autophagy. Sleep deprivation specifically impairs neuronal autophagy by elevating brain cortisol and disrupting the glymphatic system, the brain's own overnight waste clearance mechanism. So if you're fasting in hopes of protecting your brain, but sacrificing sleep to do it, you may be undermining the exact outcome you're working toward. The compounding effect runs even deeper. When sleep is disrupted, ghrelin rises and leptin falls. Hunger increases, willpower degrades. People who attempt extended fasts while sleep-deprived are significantly more likely to break their fast early, eat reactively, and spike insulin at precisely the moment when their body most needs it suppressed. So poor sleep doesn't just block autophagy chemically, it sets off a cascade that practically guarantees the fast itself won't last long enough to matter. Here is the framework that changes everything once you understand it. Fasting is not a single switch. It is a system of overlapping biological conditions that all need to be aligned simultaneously. Insulin must be low, mTOR must be suppressed, circadian clocks must be synchronized, cortisol must be controlled, growth hormone must be allowed to surge. Every one of those conditions is either directly created or severely undermined by the quality of your sleep. Fasting is the foundation, but sleep is the scaffolding that holds the entire structure up. So what does this mean practically if you fast seriously? Protecting sleep during a fast is not optional. It is as metabolically important as the fast itself. 8 hours of consolidated, deep sleep before and during an extended fast can be the difference between triggering robust autophagy and spending days hungry while your cells barely clean themselves. Getting into bed before midnight, keeping your room cool and dark, avoiding screens in the final hour of the night, these are not lifestyle suggestions. During a fast, they are performance conditions. Some researchers have even begun exploring the concept of sleep-optimized fasting windows, where the fasting period is deliberately anchored around sleep so that the body's natural nighttime autophagy surge is extended rather than interrupted. The idea is simple. If autophagy naturally peaks during deep sleep, then beginning your fast several hours before bed and ending it several hours after waking maximizes the overlap between the fasting state and the body's biological cleaning window. You are essentially stacking two of the most powerful cellular optimization tools available to you and allowing them to amplify each other instead of working in opposition. If you want to understand how to build the ideal fasting protocol from a sleep and circadian perspective, you might want to go back and watch our video on what happens inside your body hour by hour during a 24-hour fast. The two pieces connect in a way that makes both videos significantly more powerful together. Here is the final truth that most people in the fasting community still haven't confronted. The person who sleeps 8 hours and fasts 16 will almost certainly achieve more cellular repair than the person who sleeps 5 hours and fasts 24. Discipline without sleep is biology working against itself. The cells don't respect effort, they respond to conditions. And no amount of willpower, time without food or motivational intensity creates the conditions that one night of genuinely restorative sleep can provide. Your body is not a simple machine that responds to rules. It is a deeply time-sensitive, environment-dependent biological system that evolved over hundreds of thousands of years under very specific conditions, including darkness, rest, and rhythm. Fasting without honoring those conditions is like planting seeds in concrete. The intention is right, the environment is wrong. So the next time you prepare for an extended fast, give sleep the same respect you give your eating window. Track it, protect it, prioritize it. Because the science is unambiguous. Sleep isn't what happens after fasting. For autophagy, sleep is where much of the magic actually lives. If this video shifted the way you think about your fasting practice, please give it a like, it helps more people find this research. Subscribe if you want to keep exploring the science behind longevity and cellular health, and share this with someone who fasts seriously but might not have made this connection yet. Their cells will thank you.